specific resistance or resistivity. What is specific resistance or resistivity? See, we all know that resistance is directly proportional to the length of the conductor. Length increases, resistance increases, and resistance is inversely proportional to the area of cross section. If area increases or thickness increases, resistance decreases. So this can be our equation number 1 and this can be our equation number 2. So combining equation 1 and 2, we can write R is proportional to L by A. Yes? So, if you remove this proportionality, there will be a constant. R is equal to rho L by A. So, here rho is a constant. Rho is a constant. And this rho is a characteristic of the material, characteristics of the wire, and this rho is specific resistance or resistivity. So what is rho? Then rho will be R into A by L. Okay, so this rho is specific resistance. Rho is specific resistance or resistivity. Okay, actually rho is a characteristic property of the wire. Okay, now let us define resistivity. Suppose if L is equal to 1 and A is equal to 1, then we have what? Rho is equal to R. Am I right? So the specific resistivity is the resistance of a wire of unit length and unit area of cross section of that material of unit length and unit area of cross section. So any wire made of any material, if you are taking unit length and unit area of cross section, and then if you find out the resistance of that unit length and unit area of cross section, that is what is called resistivity. Okay, now we can find out the unit of specific resistance. Specific resistance, otherwise called resistivity. Okay, so unit, how to find the unit of specific resistance? We know rho is equal to RA by L. So what is the unit of? Then unit of rho will be unit of R into unit of A divided by unit of L, right? So what is that? So that is ohm into meter square divided by meter, right? So meter square and 1 meter will get cancelled, so we have ohm meter. So what is the unit of resistivity? Ohm meter. This is the unit of resistivity. Okay, now we'll see what are the factors affecting the specific resistance. Factors affecting specific resistance. See, we studied specific resistance is the characteristic property. That means it is the property of that material. So for metals and alloys, the specific resistance is very low. It is very low. In case of semiconductors, the specific resistance or resistivity is low. Okay, of the order 10 raised to minus 5 ohm meter. Here very low. We can say of the order of 10 raised to minus 8 ohm meter. For insulators, the specific resistance is very high. It is very high. It is of the order of 10 raised to 13 ohm meter. So we should know the specific resistance because we have lot of choice of material of a wire for application. We need wire for power transmission, fuse, for heating element, and resistance wire. So lot of applications. So for all that applications, we should know the value of these metals, alloys, semiconductors and insulators. Next factor is temperature. So again, specific resistance depends on temperature. So for metals, specific resistance increases with increase in temperature. Specific resistance increases with increase in temperature. For semiconductors, specific resistance decreases with increase in temperature. And for alloys, specific resistance remains almost practically constant with change in temperature. See, alloys means you can say constant and manganese. For this substance, the specific resistance remains constant, practically constant with change in temperature. So one more time, see, the second factor is the specific resistance depends on temperature. See, for metals, the specific resistance increases with increase in temperature. For semiconductors, the specific resistance decreases with increase in temperature. And for alloys, the specific resistance remains constant with change in temperature. Now we shall see conductivity. What is that? Conductivity. What is conductivity? It is represented by the symbol sigma. That is sigma. Okay? conductivity is the reciprocal of specific resistance or the reciprocal of specific resistance or resistivity. So sigma is equal to 1 by rho. Sigma is equal to 1 by rho. So you can say L by RA. So the SI unit will be, SI unit is what? That is ohm meter. Here it will be per ohm meter. Okay, or you can write per ohm per meter. This is the SI unit of conductivity.